Hi, my name is Rizwan and welcome to the Nowhere. So today we are going to solve the problem number 155, which is min stack. So imagine if we have a stack in which we can not only push and pop the value, but at the same time we can get the minimum element out of the stack. All right, so this is what we are going to do today. So don't forget to hit like, share, and also subscribe the channel. Uh, in we, we will go through this problem step by step. So in this problem, what we have to do, we have to create we have to create a stack, and also we have to get minimum element in the stack. For that, what we will try to do, we'll try to in the constructor we have initialized, we have made we'll try to make two stacks. One is the simply stack and another is minimum stack. All right, so after making two stacks, what we will do, this is the first stack. Okay, this is the second stack, which is minimum stack. This which will be the minimum stack. Okay, for example, we have an array of 2, 5, 3 and 1. All right, so when we append this stack, by append I mean when we are going to push the value inside a stack through append function. Okay, it will come here, it will become the last. Okay, inside the this is okay here, and then what we'll do is we'll try to compare it with this minimum stack. All right, after we have, remember, we have created two elements, we have two stacks we have created. One is stack and another is minimum stack. So first, when we push the value inside a stack by using the append function, after pushing it inside the stack, we will compare it with another stack, which is the minimum stack. All right, remember this, we'll compare it with the another stack, which is minimum stack, and we will get the minimum of the two. All right, inside the minimum stack, we will put the value, we will append also the minimum stack, and we will get the minimum value of the two. So for example here, but here it is empty. All right, so by default the minimum value is going to be the 2. So for example, if it is null, then by default it is going to be 2. All right, if there is nothing to be there is nothing we can compare it with. Okay, the another value is 5. So we are going to, okay, append it inside a stack, and then what we are going to do, we are going to compare it with the minimum stack. Okay, what is the top value of the minimum stack? It is 2. And what is the top value of the stack? It is 5 here. All right, after appending it is 5, and before appending it, it is 2. So what we will do is we'll compare the top value of the stack, and we'll compare the top value of the minimum stack, which is 2. Here it is 5, and we'll take the minimum of the 2. All right, we'll take the minimum value. So here we are going to do this 2. All right, and simply 3, after that it will be 3. Okay, 3, and then it will be 1. So here between 3 and 2 it will be 2, and between 1 and 2 it will be 1. All right, so even after we pop, look at the stack, if we by pop I mean removing the last element. All right, so even after we pop, for example, if we pop this 1 here, okay, we will still get the minimum stack. If we are going to pop 1 from here, we'll get the minimum stack. Or minimum stack will be 2. All right, even okay, this is it. We remove the we remove the 3 here from here, and 2 will be removed from the minimum stack. Still we get the minimum stack, minimum element will be 2. We remove the 5, we remove 2 here, still we get the minimum value as minimum will be 2. So 2 it will be until it gets empty. All right, so this is actually what we are trying to discuss, and now we will move towards the code. Okay, after initializing the constructor, and we will work with the push function, so how we are going to make a push, we'll simply make self.stack.append. We are appending the self stack, all right? The stack named itself, we have itself named stack. We are going to append it with the value. We have, we have mentioned here. Okay, now we are working with a condition. If self dot min stack, it means if self dot min stack is not empty. All right. So we have worked. If this is empty, if this is not empty, or all right, it means if here one and two here it will be one. So it means if there is something already present in the min stack, this is min stack, and this is stack. If this is if there is an element already present in the minimum stack, what we'll do is value will be minimum of value, and self min stack minus one we are indexing here. It means the last value of the minimum stack, which will be the top value of the stack. All right. So the last value will be the top value, as we have already as I have already told you. For example, if this is an array on 2, 3, 4, in the stack it will be 1, 2, 3, 4. So the last value will be the top value. All right. So, uh, inside if there is already something present, if there is already an element, or the minimum stack is not null or empty, then we will take the minimum of these two values, whatever is minimum, and we will append it to the minimum stack. Okay, there is already, this is one. This is what we are trying to do. Okay, else if there is not, if there is um, if there is if the minimum stack is empty or it is null, so else what we are going to do, value is will be equal to value, and then we will append, we'll do the same operation we did here. All right, we are going to append the minimum stack. And also coming to the pop function. Okay, this is the pop function we are going to work with now. Pop is simple. We have to, self.stack.pop and self.minStack.pop. If we remove any function, we have to remove it. We remove the same element. If we have to remove an element which will be at the top of the function, pop will automatically remove the element which is at the top of the stack. All right. So we remove the same. We have to remove, but we have to remove it for the both, because if we remove it from the one place, we have to remove it from here also. Okay, if we're going to remove it here, we'll remove it from here also. So it will be self dot minimum stack dot pop, and both in the both stacks we are going to pop the value. Okay, and then top we know how to return the top. We have already used this here also. Self dot min stack and -1. So the index will be -1 here. So we will return the -1, which will be the top of the stack. All right, the element which will be at the top of the stack. This function will return the top element. And also return get min function. It will simply, we have to get min stack dot 1. So for example, if here is 2, we already gone through this. If here is 2 and here will be 1. All right. If here is 1 and here will be 1 also, so the at the top it will be 1. Okay, unless and until there is 0 present here, then it will be 0. So at the top, whatever is at the top will be the minimum. We as we have discussed, whatever is at the top of the minimum stack will be the minimum, will be the minimum will be the minimum element present in the whole stack. If we pop this 0 here, what will be the minimum element? Of course, it is going to be 1. So in this tutorial, or in this problem, what we are trying to do is we are pushing, popping, and also we are getting the top, and we are also getting the minimum element in the constant time. All right. So we have completed the problem. So I hope you like it, and give me the better suggestions in the comment section. I will appreciate your feedback. So thank you till the next video. Bye bye.